All right, we're getting ready to put the S10 back on the dyno tonight, hopefully. Last time we were able to replicate what's happening on the track on the dyno. So we had tried putting a support on that brace and that really didn't seem to help anything. So Phil's gonna come down with his picoscope where he can actually watch raw data, and it gives him a lot better idea of what's actually going on, whether the sensor is outside of its capabilities or whether it's skipping teeth or what it's doing. We should be able to figure that out. So in the meantime, we're trying to address some of our oil leaks. We had the valve cover was leaking some, so we're ending up clearancing a few surfaces that should give us a little bit harder clamp load on the valve cover. And then we're also addressing some of our breather tubes. So felt like we had a little bit plenty much restriction. We know that we have a little bit more blow by than what we would like to have. So we're also addressing some issues that we had with our catch can. We're increasing the size of the breather tube going from the valve cover over here to the catch can. So the engine breather comes from the valve cover into the oil tank, and then from the oil tank there's a breather tube that runs out back to our catch can and breather. That way if there's any kind of oil spillage, it's all behind the tire. So we only had a -12 line running there, and we're increasing that to a -16. So that's increasing our breather capacity by about 40%. Last year we had added this second port for the second sump section on the oil sump, and when we had done that we didn't have a good diverter inside of it, and so it would really splash into the tank quite a bit, and it would make it really difficult to check oil level while the truck's running. And then we also think we were getting some splash from that port up here into our breather port, so we were pushing extra oil back into the catch can that was unnecessary. So we ended up cutting that bung out and adding a 90-degree elbow on the inside of it to kind of redirect that oil and try to make it flow all with the rest of it. So hopefully that'll address some of our oil flow and breather issues.
I'll catch him if he falls. I'd like to see that. I was Larson that just falls and see what happens.
It's not going to go from that point.
Why?
Because the whole self-tapper is rounded off, I promise.
Well, I made a hole in it already.
Yeah.
All I gotta do is get the catch.
Yeah, so now take that out and put a new one in.
This is why you don't work with brothers. They all fight 25-7. 45-7? 25, 26, 25-8?
I bet that's hot.
He's gonna burn his hand trying to get the torch away from him.
Yeah, he's gonna have a state fire, bro. Yeah, look, you just burned his confidence.
I'm not taking that chance.
Okay, we've got the picoscope hooked up to the crank sensor. Phil is from Expertise down here, and we're just going to make a few lovely pull like we did a couple Saturdays ago and try to get actually the data to see what's going on. Here you can see on the picoscope, you can see every tone that it picks up. It's 60 minus 2, so 50/18 in the gap. That's for top dead center. And we'll be able to see at high RPM, is it missing 1 teeth, 2? Is it skipping? Is it cutting out? Like, give us a better idea. Is it the sensor actually dropping signal? Are we missing 1 or 2 teeth if the crank's deflecting or something like that? So that's what we're trying to do, is just try to identify what the actual problem is. So we're going to make another pass on the dyno, see if we can figure this out.
Zoom out to a little wider time base, just because here I wanted to get really good resolution, but you can see it might have missed. It's possible for it to miss part of a revolution because, like, you know, we have a gap here. When we go to the next frame, we have a gap here. Well, there's
Okay, so we got the data that we wanted. The Pico scope showed no smoking guns per se with the crank signal. We were seeing a little bit of noise in the crank signal, but it was still a solid 58 tones with a 2-tone gap all the way through, even when we were having the cutout. So the next thing we're going to do is run the troubleshooter on the Bosch while we're connected on the next pass, and that's going to show us a couple different fuel modes, and crank signal just gives you access to everything that's going on in the ECM, a little bit more than data than what we have through the logger that we run on the track, because it just goes into the troubleshooting mode. So we're going to run that and make sure that we can't find anything in there, and then we're going to go from there. So right now it's just about collecting data. Okay, this time we put the breakout box on it, and this is going to read the crank signal at the ECM. So we know the crank signal out at the sensor is looking good. So this is going to tell us if we lose crank signal in the wiring harness. It's a shielded wiring harness, but there is a place where it goes through the wire firewall and a bulkhead connection that it's, you know, a little bit of unshielded wire. So the breakout box will tell us if our crank signal at the ECM looks the same as at the sensor, and that'll diagnose whether it's a wiring harness problem or not.
I'm guessing it's just because not all these are being sent on the CAN bus at the same speed. And I'm guessing if it happened really quickly, it's possible that you just missed it.
Okay, to wrap up for today, we collected a lot of data. We saw the information at the ECM, and that actually looked like a pretty good signal. We see a couple little bounces of voltage. I mean, you're talking like 0.8 of a nanosecond. So like, I have a hard time, it's still getting a full signal. We're not losing any tones or pulses per rev. So what we're going to do is take this data, go back and study it. Phil DeVries from Exergy, he's one of their mechanical engineers. He's going to go back and study this data and just see if he can collect any information that would possibly help us pinpoint this problem, and then we're going to move forward from there. All right, we are wanting to update you guys on what we found on this cutout issue. This was something that really made ourselves bang our head on the wall, and turns out it was something very simple in programming. So we collected all this data, we scoped all the crank sensor signals, everything, because of the fuel mode that the ECM was going into was showing loss of crank signal. Well, it was going loss of crank signal because it was shutting fuel off so hard. It was temporarily losing crank signal. But what we found is Phil DeVries from Exergy was putting together all this data and was going to write a detailed report to one of the Bosch engineers to see if we could come up with an idea of what could be possibly causing this. And in the process of him digging deep, doing his research to make a case to Bosch, he found buried in the software an additional limiter that was set at 5,900 RPM. So pretty much we'd come up right to 5,900 RPM, and it would cut the engine out. And we were able to find that limiter, drag it into our tune file, change it up to 6,800 RPM, and the thing soars full fuel to whatever RPM I set that to. So we are clear for high RPM running. We shouldn't have any cutout issues running it out the back door. We were really hoping to get a different gear ratio in here to where we could have a little bit more mile per hour on the back end without running 6,500 RPM. But the gears are a custom made set of gears, because most of the gas cars would have RPM, so they don't have to deal with such a low gear ratio. We got a 290 rear gear, and we were trying to go to 273. But the truck is all buttoned up. We're ready to put it in the trailer for SGMP. This is Lights Out 13, and we're hoping to put this truck back in the 3s this week.